Oh hey guys, I am back with another banger on top of another banger, guys. If you're new to the family, please don't forget to like, share, and subscribe, guys. So today we are going to be covering what conservation of linear momentum. But before we can dwell into these examples that I've written here, let's define a conservation of linear momentum. What is the conservation of linear momentum? Conservation of linear momentum states that the total linear momentum in an isolated system will be conserved. Whatever. So that is a what? The conservation of linear momentum. So now let's describe what the first scenario, and then I'll describe even what this second scenario. So if you want to state a conservation of linear momentum, you can write it like this: the sum of the initial momentum is equal to the sum of the final momentum. So if you want to simplify it further, you are going to write it like this. So this is what scenario number one, whereby object 1 and object 2 are head-on collision. So this is what the initial scenario, and then on the final velocity scenario, it's when these blocks has collided to each other, and now they are moving in the opposite direction. So that is what this is the first scenario, and this is the formula that you should write this thing. You should write this thing. The way yeah. And this is number two. So number two, we find object A, it is accelerating to our right, and then object 2, it is resting. So when object 2 it is resting, the velocity it is going to be what? 0 meters per second. So this is what the initial velocity, and then on scenario on the final scenario, object 1 it now collides with what? With object 2, whereby they start to move in the same direction together. So its formula, going to write it how you're going to write it like this. So why do you say m2 plus m1 plus m2 multiplied by v final? It is because now they are moving in the same final velocity. So now let's do an exam question. Okay guys, so now we are going to do an exam question, guys. Okay, so we're still continuing with conservation of linear momentum. So we have a oh hey guys, so now we are continuing with what? Conservation of linear momentum. So now we'll be doing what? An exam question. So it says what? Object B of mass 2 kg moving east. So if you don't know where's east, you can say we. East is that way and west is that way. Okay, moving east at a speed of 10 meters per second, collide head-on with another object Q, with mass of 1,5 kg. So such statement you highlight them. Okay, moving west at a speed of 15 meters per second. So I think from this scenario they're talking about what? Before the collision. Okay, then they say after the collision, object P moves west at a speed of 5 meters per second. Calculate the velocity of the object after collision. So guys, momentum, it is a vector quantity. Before you can start with the calculations, what do you have to do? You have to assign the direction. So I'm going to say what? Let east be positive. So in this case, look at our two blocks. They were not combined after the collision. The other one went that way and the other one will go that way. And then when you write the formula, you'll see what? M1 VI plus M2 VI is equals to what? M1 VF plus m2 and what vf. And then from now on you do what? You substitute the what? The formula. But before we can do that, let's extract the data first. Data. Okay, the mass of P. The mass of P is what? It is 2 kg. And then the mass of Q, it is what? It is 1,5 kg. So from our example there, we can actually see that our masses are in the right SI unit. Whatever. And then we have what? We have a block P that is moving in which direction? Velocity of Q initial, it is moving eastward. It means we'll have what? A positive 10 meters per second. And then VP, VP, it's VP. And then Q, negative 15 meters per second. Okay, so this is the initial velocity for what? For block Q, and this is what the initial velocity for block Q, whatever. And then we'll write what? The final velocity for block P, which is what? Negative 5 meters per second. Why did I write negative 5? It's because of it is moving what? It is moving westward, and I assign my direction as what? As let east be positive. And then you just do what? You just substitute your things on the formula. You say what? 2 multiplied by what? By 10 plus 1,5 multiplied by, what's this? Okay, multiplied by, okay, negative 15 is equaling to, let's see, what is our initial velocity? 2 multiplied by what? Negative 5 plus 1,5 multiplied by what? By VF. So we are looking for what? We are looking for VF. So for us to find VF, we are going to do what? The mathematical gymnastics. Okay, so fortunately I've found what my calculator will say 2 multiplied by 10, which is 20, plus 1,5 multiplied by 15, it gives us what? Negative 22,5. And then we are done with this side, and then we'll multiply this one. It's going to be what? Negative 10 plus what? 1,5 VF. You get it? And then check. This is what? Algebra. 20 minus 22,5, we get what? 2,5 minus what? 10 plus 1,5 VF. By one. So let me continue my calculation in this side. So we're going to transpose what? The 10 to our left hand side, and we'll have what? 2,5 plus 10 is equal to what? 1,5 VF. And then we'll get what? 12,5, 1,5 VF. So we'll do what? We'll divide by 1,5 to find our VKF, and then divide by 1,5 to get what? Our VF. And then our VF, it is what? It is 8,33. So since it is a vector quantity, since the velocity is a vector quantity, we'll actually assign the direction. We'll say 8,3 meters per second to the east. 8,3 meters per second to the east. Okay guys, please don't forget to like, share and subscribe. Danko.